Hey everyone, it's 31K Vanta here with the guide on FTC Turrets. Just thought I'd hop on and make this video because turrets are like basically a necessity in this year's game, so I think it'd be kind of nice to explain them. My name is Shrey, and I'll be telling you all about them today. So yeah, let's do it. So what makes an effective FTC turret? So a turret allows a robot to rotate a mechanism independently from the drivetrain, improving accuracy and efficiency. An effective turret must rotate smoothly, resist skipping, and remain consistent under impacts. And the main design priorities are reliability, stiffness, and ease of maintenance. Simpler, more forgiving designs perform better over an entire competitive season. And I think another important part is kind of like, yeah, it says over here that it must rotate smoothly, resist skipping, and remain consistent under impacts. I think especially in this year's game, that's extremely important because like you kind of want to have a turret that can kind of move all throughout, like move as you're moving through the field because it's kind of nice to like be able to shoot and you don't have to stay in one place. Powering the turret. So we're kind of explaining why pulleys work the best. So as you know, turrets can be powered using gears or pulley systems. While gears provide precise ratios, they require extreme accurate alignment and can skip or wear when the frame flexes. Pulleys and belt systems are the most forgiving because of misalignment, and they absorb shock from collisions. Belts significantly reduce backlash and noise, leading to smoother and more consistent aiming. For FTC conditions, pulleys offer higher reliability and easier adjustment, and pulleys are what we use. Designing for control and torque. The pulley ratio should balance torque and rotational speed. Larger driven pulleys increase torque and improve control. Excessive rotation speed reduces aiming accuracy, which means that smooth, predictable motion is more important than fast rotation. Proper belt tension ensures consistent performance without slipping. So you should always support the turret with bearings as can be shown over here because bearings support the turret's weight and handle rotational forces. They must manage both radial loads from rotation and axial loads from mounted mechanisms. Poor bearing support causes wobble binding and inconsistent performance. Bearing choices directly impact turret accuracy and durability. Why one large bearing is the best choice. So a single large bearing, such as a 6-inch X contact bearing, which is what we use, distributed loads evenly. It increases stiffness and reduces turret wobble. Using one bearing simplifies the design and reduces alignment issues. And that's a good thing because fewer components means fewer failure points and easier maintenance for the build team. This setup is ideal for precision-based turrets. Structural design best practices. So you should kind of make sure that you keep your turret low profile because if it's really like kind of like big and stuff like that, then it'll have more torque, which isn't that good. So yeah, you want to keep it low profile to reduce torque loads. You want to center the mass of the mechanism over the bearing when it's possible and use rigid mounting plates to prevent flex. You want to avoid cantilevered loads that stress bearings and belts, and you also want a high structural stiffness because it improves repeatability and accuracy. Final design strategy. So when you're making your turret, you should make sure that you have a pulley and belt system for smooth, reliable power transmission. You should support the turret with one large bearing for maximum stability. And you should prioritize stiffness, as we said before, simplicity, and consistency over a really complex turret that might not work so well. An effective turret is designed to perform reliably every match, which you definitely need if you want to make it to your state championship. And a special thanks to all of our sponsors, without whom we would not be where we are today. Thank you.